To help out with the machine design industry, we've added some great new enhancements to the motion simulation product. The first one is the ability to apply a motor to an object that's defined constrained by a pathmate. So when you add a motor now, you have a third option here, which is define a pathmate. In Solidworks, you can define pathmates, which are basically points which have to follow an arbitrary profile. So for example, in this instance, the point here is free to travel around the conveyor path. So it's a very powerful tool for doing things like overhead cranes, conveyors, roller coasters, all those types of things. You can now drive things along those paths with specified speeds or whatever function you need. So you can see here you've got access to all of the existing types of functions. What's powerful also is that because it's really what we call a kinematic or controlled, there's not that much overhead of defining them. In this case, what we have is we've got pathmate motors on each leaf of this belt to transport these barrels from a lower position up to a holding station. So you can see here we've got contacts defined, which is with friction to lift up the barrel, and then you'll see it rotate when it gets dumped off. But again, because it's a fully defined motion, the pathmate motors have very little overhead to the analysis. The main calculation time here is for the contacts. So a very powerful tool to help us simulate the operation of our equipment, as well as doing more of the pick and place or transfer operations more accurately. Now if we take that one level further, we can look at it with all of the barrels in tow, and this one takes a little bit longer to run obviously because of the more contacts, but again really helps us out in not only understanding what's going on with our system, but also if you want to convey things to other people, it's another powerful tool in that respect. Okay, the other area we've spent some time is in focusing on functions. When you have complex equipment, the operation of that equipment can be very difficult to move. So what we've added is the ability to define functions using segments. And what we mean by that is sort of how you would define operation sequences. So you ramp something to go from point A to point B, dwell at a certain position, and then ramp it back down. So for example, when we're picking up this rack of towels, so we have our existing functions here, such as constant speed, distance, oscillating, and so on, as well as any custom functions that we may want to define. For example, here we can see how that is set up. When we use the segments option, we just come in and very easily say over half a second we want to ramp up to 800 millimeters for our lift operation, and then we determine how we interpolate that. Is it a linear interpolation, so it goes up quickly, and we get great feedback understanding what the acceleration, velocity, and even the jerk is going to be with that interpolation. Then we've got our dwell at the top, and then from 1.5 to 2 seconds we ramp back down to 0, and that's when we're doing our drop operation, and then we repeat that to come back to our original position. So we have functions like that set up for our lift operation and then for our transfer across, which gives us the resulting outcome where we pick up the package and we drop it down. Now to release it, what we've done is just added a couple of mates to turn on to lock the package to the lifting equipment and then to the box afterwards. Now we can also apply that to the entire system. We can add pathmate motors to drive our conveyor elements, and we can add our movements to sequence our operation. So if we replay that, we can advance our conveyor, pick up our box, transfer it across, eject the box, pick up the next box, and so on. So it's a very powerful tool for helping us get our sequencing correct and more accurately representing the functions that we use to drive our systems.